This is a video covering section 3.6. In this section, we're looking at how to determine whether an argument is valid or not. And using a truth table is going to be one way of determining that. Now, by argument, what we mean is just a collection of sentences, that something like what you see here. Okay? Now, sometimes the string of sentences seem logical, seems like a valid, perfectly valid argument, but when you do the truth table, you might find out otherwise. Okay? For this argument to be valid, you're going to need to have that the final answer is true all the way down the line when you do your truth table, that the final answer for every case turns out to be true. All right, so you already have the skill of doing a truth table. So we're going to be learning how to create the compound statements for an argument such as what you see right here. Then all we need to do is the truth table for that. And if it turns out to be all true, then we know the argument was valid. So the first page is, excuse me. The first page was just outlining the process. And then we'll streamline it a little bit as we do the next problems. So let's just look at the steps that you're going to wind up doing. Let me get it back to one page. Okay. All right, so the first step is going to be to decide on how many letters you need and which sentence they represent. So you assign a letter to represent each statement. Okay? Then you translate the sentences into symbols. Okay, that's step 2. Then that's the next one. Step 3 is the new skill. Step 3 is when you try to figure out how to hook all of those together into one compound statement. And then once you've done that, you're just going to complete the truth table. And if you get true all the way down the line, then you know the argument was valid. So with this particular one, I'm letting P stand for there is a problem, and letting Q stand for I must fix it. Now in reality, I like to do steps 1 and 2 up here, right next to where the argument is written. Because as I go through it, I think, okay, if there is a problem, so that's P, then I must fix it. So if then would look like that. That's premise 1, that first sentence. Okay? There is a problem is the next statement, and that's P. That's premise 2. And then the last statement, I must fix it, is below this line. Okay? And that's Q. That's the conclusion, what's below the line. That line that you see really stands for therefore. So that line right there, I don't know how to indicate. This line right here stands for therefore. It's telling you that what's below that line is the conclusion. Okay? So the horizontal line, 3 dots are sometimes used for this, or you might see them actually use the word therefore in the argument. Any one of those 3 things mean that what follows that line would be the conclusion. Okay? Now, once you get each sentence translated, what step 3 says you're going to do is this, and this is how it always works. Oh, let me comment on premises. A premise is like a proposition that you assume to be true. It's an assumption or something, not assumed to be true, but it's something that you're assuming, okay? So you can have more than just 2 premises. You could have like 3 or 4. You typically won't. You'll typically have just 2 or 3. All right? So you're trying to write one statement that represents this whole thing, this whole argument. And it's always, always, always done this same way. You take your premises. So you're going to take premise 1, premise 2, and you're going to hook them together with an and. Okay? And then once you've done that, you're going to see if premise 1 and premise 2 implies the conclusion. Okay? So between the premises will always be ands, and then between all the premises that have been hooked together with ands and the conclusion, you have your if-then. Okay? So the symbolic statement for this argument would be P implies Q and Q and P, because that's premise 1 and premise 2. So you're going to do P implies Q. Then you've got to do P implies Q and P. Then you're going to see if that implies the conclusion, which was Q. So this right here, this thing I just wrote, is the symbolic statement for that entire argument. So now you're going to think about how you want to do your truth table. So one thing you might do is go ahead and figure out P implies Q. Okay. And then go ahead and figure out what P implies Q and P turns out to be, because that'll give you the answer to this whole first part. And then finally do P implies Q and P implies Q. Okay? All right, now we're just going to get to work. So P implies Q, that's the broken promise one. And P and Q are in the normal order. And the only time that's false is if P is true and Q is false. All right, now for the next one, I need to be working on this and right here. And I need to be looking at the column with the P implies Q and the column, I don't know why I did that, and the column with the P in it, those two. Now, what you might choose to do is to just transfer your answer to P implies Q and P over here, so they're right in front of you. Then you're going to do an and of that. So 2 trues are required for it to be true. So you're going to get true, false, false, false. Okay? So now that's the answer right there to this part that's in brackets. So the answer to that was true, false, false, false. And I'm having to put that together with P, with Q, which was true, false, true, false. All right, and then it's asking me on this to finally do that, which again is the broken promise. So I'm looking at true followed by true. Anything that starts false, we know is going to be true. And then that's our final answer. And since they're all true, so we know the argument is valid. Because it turned out to be true for all cases of the individual, for all of these cases, all 4 of the cases. Okay, so that's kind of the mechanics that we're going to use when we're trying to determine if an argument is valid, at least to start with. We're just going to be using truth tables to figure that out. All right, so let's look at questions 2 and 3. We're going to streamline the process a little bit. So steps 1 through 3 are basically trying to convert the argument into a one symbolic statement. All right, so I like to start by, as I read through it, I can avoid sweets, I'll call that P. Avoid the dentist, that's going to be Q. Can't avoid the dentist has a not in it, so that's going to be not Q. Can't avoid sweets, that's back to not P. And then I put in the right connector. So I'm thinking about P implies Q is the first sentence. I can't avoid the dentist is not Q. And then below the line that means therefore, I have I can't avoid sweets. So that would be not P. Now, when I go to hook that together to make the compound statement, I have to take my first premise, which is P implies Q, hook it together with my second premise, which is not Q. So I'd have to do that and then get the value for what all the premises hooked together would be. And then I'm going to see if that implies the conclusion, which is not P. So do you see how you wind up using the and to hook the premises, and then you make a big if-then statement to see if you wind up, if those premises lead you to that conclusion. Okay? All right, so you can do as much scratch work as you want on this ahead of time. On this one, let me remind you that you can do that one where you kind of stretch things out a little bit so you have room to write. Go ahead and get those grouping symbols that remind you what you need to work out. But kind of leave a little room in there because I'm going to be using that shortcut method. All right. Now, I see P implies Q in the innermost set of parentheses. So I'm going to do that first. And it's P implies Q. So that's the normal order, and these are in that order. So I'm going to just think about the broken promise, right? So it's going to be true unless I have true followed by false. Okay. So there it is, T, F, T, T. Now before I can do the and, I need to do my not Q. So my not Q would be false, true, false, true. All right, now I'm going to be working on the and here, looking at the two columns that you see. So true and false, that would be false. False and true would be false. True and false would be false. But then two trues would be true. So what you see in green is the answer to the whole bracketed first part, right? So I'm done with this and this. This is the answer to the whole bracketed first part. Now, I'm going to need to do the if-then. But before I can, I need the not P. So I'm going to go do my not P, which would be false, false, true, true. All right, now I'm going to go back and I'm going to work on the if-then, the broken promise one. And what I got to focus on are the two things you see in green. And I know with the broken promise, if it starts false, it's going to be true no matter what. And then the last one is true followed by true, so it's also true. Okay, that's my answer column. And they're all true, so the argument is valid. Okay. Let me do one more on this video, and then I'll stop it so they don't get too long. Let's try another one while we're on a roll. Okay. All right, so on this one it says, if our guests arrive before lunch, we'll eat out. So guest arriving before lunch and eating out, that would be our P and Q. And it's an if-then, even though I don't see the word then, then is implied right there. So that first sentence would be a P implies Q. We ate out is actually a Q, and our guest arrived before lunch is below the line, and that's a P. Okay. So when I go to string this together, I have my premise, first premise, okay, that I need to put together with the second premise using an and. I need to get the value of all of that and see if that implies the conclusion, which is P. Okay. So I have P implies Q and Q, and then implies P over here. Okay. So P implies Q. All right, that's normal order. I'm looking at the P and the Q column as I do it, and I'm thinking broken promise. So this has happened several times. That would be true, false, true, true. Q by itself, I'm going to go ahead and jot down, is TF, TF. So when I go and I do the and here, I need to be thinking how both have to be true. So that one's true. Both have to be true. So I get TF, TF. All right, now that column TF, TF, that's the answer to the bracketed part. So I'm done with this, I'm done with this. So what I need to do now is use that column and P by itself. And P is true, true, false, false. Okay. So I'm going to use these two columns, and I'm going to be thinking about, let me see, I'm going to use a purple. I'm going to be thinking about the broken promise now. So I'm going to do true implies true, which would be true. False implies true. True implies false would be false. And then false implies false would be true. Okay. So that's my final answer column right there. Okay. But they're not all true, okay? So it's not true for all cases. So the argument is not valid.